All right, welcome everybody. My name is Sophie. We're going to kick off now because I want to reward those of you who are here on time. Kia ora to Laura. So I am going to just start us off with a wee karakia. So just want to acknowledge that the talk is supported by Henderson Massey Local Board, who fund the Īnanga project that Community Waitākere works on. If you would like to practice your te reo pronunciation, I'll be saying it and you can have a practice at home with it muted. The translation's on the right. So, me noi tātou. Tū taua mai I runga, tū taua mai I raro, tū taua mai I waho, tū taua mai I roto. Kia tau ai, te mauri tū, te mauri ora, ki te katoa. Haumie, huie, tai kie. So guys, welcome along. As I said before, my name is Sophie Barclay and I work for Community Waitākere. And tonight you're here to learn all about this fish here, the Īnanga, also known as our native whitebait. We've got some great people on board. We've got Ella Wormsley, who stepped in at the last moment like a true champ. She's from Whitebait Connection and her colleague Sarah was supposed to do the talk tonight. So I'm sure she's going to do a really great job. We've got my pal and longtime mentor, Matt Bloxham, who's a senior ecologist at Auckland Council, and he knows everything about fish, and I've pestered him with heaps of questions over the year, so really great to have you along, Matt, and he'll be talking about fish passage. Ella's going to give you a bit of an Īnanga 101, and then I'm going to be talking about a project based in the Henderson Massey area called Ngā Puna Manaaki Īnanga, or the kind of pool of support for Īnanga. And then we'll also be having a Q&A session. So please feel free to send through your questions at any time. We'll make sure that we've got enough time to address those at the end. So, hold up a wee seckie. This is just a brief slide about Community Waitākere for those of you who don't know what we do. So we're based in Henderson or Te Kopua, and we work for a connected, thriving and sustainable West Auckland. We work across the environment and the community, and we're connecting people to place. We offer training, events, opportunities to get involved, and we do a lot of stuff around citizen science, which is pretty cool. This is a quick promo for a wee event next Tuesday, part of the EcoFest West Festival. If you haven't checked it out, there's so many events on it, it's not even funny. This is going to be a really cool one. It's about sort of climate related solutions. There'll be a guide talking about the concept of the 20-minute city, who is a professor at Waikato Uni. And we're going to be having Kathy Livermore, who'll be talking about collectives and systems change, and then we're also going to be having someone talking about the circular economy and degrowth. So if you're interested in that, you can check it out on Community Waitakere's Facebook page or on the EcoFest West website, and I really recommend you check out some of those events. So let's kick it off. And actually, before I continue, we're going to see a video by Cherie, and she was meant to join us tonight, but unfortunately our schedules couldn't align. So I just want to acknowledge that she was going to provide a kind of a grounding in Te Ao Māori for us and talk a lot about the Mauri of water and some other information about Īnanga. So we don't quite have that base covered. So I just wanted to acknowledge that. But here's a wee video from Cherie about Īnanga.
Whitebait is a sort of a collective term for those lovely sparkly fish that we collect and we put in our omelettes, and it tastes really good. But there's actually 5 different galaxid species in there. We have the giant kōkapu, the banded kōkapu, short-jaw kōkapu, kōaro, and then the most common one, which is the Īnanga. Our people at Te Puaha also talk about whitebait, including at least one other species. They call it the number 2 whitebait, and that's the common smelt, or our people call it porohe. The Īnanga is the most common one, and They tend to like spawning in the more estuarine, so slightly salty water. They lay their eggs in the grassy verges, so literally a big king tide comes up the river from the ocean and lifts the water level, and the fish use that water level to get into the grassy verges on the edge, and they lay their eggs in there. And then the water level will drop again, and those eggs are sort of left there in these nice moist environments. And then the next king tide comes in, lifts the water surface up again and washes the larvae out to sea. And so they are out there somewhere in the 200 nautical mile zone area, and there are question marks as to what is actually happening to them out there. The other fish, the kōkopū and the koaro, again, there's a question marks really about their spawning habitat. So a lot's known about Īnanga because they're the most obvious to see, and there's heaps of them. But the kōkopū and the koaro tend to like the rocky, densely overhanging streams and tributaries. We're working with Niwa to train some of our people up who live in those tributary catchment areas, giving them the skills to perhaps go out and start monitoring and trying to find out more information about their kōkopū and their koaro.
Cool, that's just a very brief little video from Cherie. So Īnanga, also known as whitebait, its current conservation status is at risk declining, and there's lots of reasons for this. Obviously, the second kind of title was Our Whitebait at Risk, so I want to explain a little bit about that before we hear from Ella. So one of the issues is that 2/3 of our rivers are not in very good shape, and I'll show you a video on that in a second. There's been some work done recently by Doc to kind of talk to people and understand how they feel about the fishery and how it could be better managed. And they've been talking about these things called refuge areas where you can't take whitebait. But then it also talks about the fact that whitebaiters might really move to those other areas and hammer them. And obviously we know that you can eat whitebait, and there's no limit to the amount of whitebait that you can fish, which is a little bit of an issue for me personally, because we are taking a lot and there's no limits. So I'm just going to quickly show you this video, which explains a little bit about the habitat within which the Īnanga lives, namely our rivers.
Today is World Rivers Day, but New Zealand has very little to celebrate. A new report details how nearly 2/3 of monitored rivers are ecologically impaired. That means animals like insects, which are an important part of the food chain, aren't living in them. The same proportion of rivers are contaminated by E. coli. The worst rivers are found in urban areas. 4 out of 5 monitored urban waterway sites are severely polluted. Keisha Brownlee reports.
The Heathcote River may be good enough for the ducks, but it's what's beneath the surface that's causing concern.
2/3 of our streams and our rivers are unhealthy for things to live in.
Things like insect larvae, an important part of the food chain that our rivers are too dirty for. In a new report from Land, Air, Water Aotearoa, experts analyse the lack of macroinvertebrates from more than 1,500 waterways. And we are to blame.
Humans have an impact on our water quality, and it's really quite major. And it's not changing a lot.
2/3 of our waterways have high readings of E. coli. Our poorest rivers are in urban catchments. Rural waterways aren't in good shape either. No surprise, the healthiest rivers are near native vegetation.
There's Karamiko, there's Pittosporum, there's several grasses.
The Opawaho Heathcote River Network has been planting natives along the Heathcote River, trying to improve water quality.
If we can all respect the river more, then the river's got a better chance of getting better. You know, it's had a history of it being exploited and used and abused over its life.
Experts say our waterways need more people like Malcolm Long. Their health depends on it.
Over the next 3 years, regional councils and unitary councils around the country will be engaging our communities in limit setting around freshwater quality and quantity. And there's an awful lot of restoration work that we need to do.
It's as simple as watching what you pour down the drain.
It's not about urban-rural. We're all in it together. We all have an impact, and we all need to think about the way that we live our lives.
Up until now, we've been the biggest problem, but we can also be the solution. Keisha Brownlee, News Hub.
Sorry, you didn't hear that whole spiel because I was on mute. We don't want tonight to be a doom and gloom. It's not about that. It's just acknowledging that there are some issues, but we're also looking at what Matt is doing, what I am doing, and what Ella is doing through their work to improve things for Īnanga, and even maybe what you can do at home. Right. So I think now we're not going over to Sarah. I'm sorry. We are going to go over to Ella. And Ella is from the Whitebait Connection. And I will leave it to her to talk a little bit about the Whitebait Connection and what they do. So I'm going to stop sharing, Ella, and it's over to you. Just want to make sure you're unmuted as well, Ella.
Yeah. Can you hear me?
Can hear you loud and clear.
Awesome. Okay. Kia ora koutou, ko Ella tukoingoa, ko kainmahi aho no Whitebait Connection. So I work for Whitebait Connection doing community and schools freshwater education. But today we're going to do a bit more of a focus on Īnanga. As Sophie said, kind of going a bit more in depth into the video, some of the points that Cherie touched on. So we're going to learn what whitebait are, where they are, why we should look after them, and then also how they are threatened currently. So as was in the video from Cherie, whitebait is a collective term for the juvenile form of 5 different species of fish. That's from the Galaxid family, and our Īnanga are one of those species. They make up approximately 95% of a whitebait catch, and they are the smallest species compared to some of the bigger ones, which can grow up to 40 centimeters. These grow usually 110 millimeters, or sometimes we see them up to like 13 centimeters. So yeah, these are our 5 different whitebait species. We've got the Īnanga there, which we are focusing on today, but as you can see, a lot of these fish are at risk at various stages according to DOC's different limits on there. As it also says here, Īnanga are pretty special fish, and they are the smallest ones, but they also are the ones that generally stay in the lowland areas of our rivers. So Īnanga have a really interesting life cycle because they are diadromous. That means that they spend part of their life in the freshwater and part of their life cycle in the saline environment, in the marine environment. So if we start off looking at our adult stage, we can see that they are in the freshwater environment, and that's where they grow up into their adult form. And the adults come back down to the estuarine environment where the saltwater and the freshwater mix, and that's where they lay their eggs in approximately autumn. So we're just heading into Īnanga spawning season. The larvae, once they hatch, they head out to sea, spend about 6 months in the sea, and then as they grow up into whitebait during spring, around November-ish, depending on where you are in the country, they'll head back up into our rivers to hopefully grow up nice and healthy into our adults again. So going a bit more into the different stages, the life stages of these fish. So these, the little picture on the left here is of our Īnanga eggs. These are 1 to 2 millimeters wide, super small. They look just like water droplets when you are looking for them in amongst the grass. So these eggs are laid in dense root mats, and they're laid on our high, like spring tides around the new and the full moon. They will spend a couple, 2 to 4 weeks above water level, hoping to keep nice and safe there. And that was so that they are out of the way of aquatic predators. And as it also says here, the adults can lay up to 3,000 eggs at a time. which is a lot of eggs to have to look after. These eggs go through a few different developmental stages in the time that they are above the water level, and they'll go through those stages faster if the environment is warmer. When they hatch, after 2 to 4 weeks, depending on tides and when they get next inundated, they will hatch in the next flood of the river when the tide comes back up nice and high, and they'll hatch into these larvae stage. These larvae are pretty tiny, only about 1 centimetre long, and they carry a little packed lunch with them under their tummy. And that's because in their first week or so of life, they are not actually big enough to be able to eat very much or find food for themselves at all. And so they have to carry that little packed lunch with them. This is the stage when they, once they hatch, they are like caught by the flow of the water and they're taken out to sea. They'll spend about 6 months out at sea. At first, they can't really do anything apart from float on the currents, and they can get out really, really far from the land. This stage of the life cycle means that there is lots of chance for different fish populations to mix around, so that the larvae don't necessarily come back to the river that they were hatched at. They can head way off into the coast, but it's really hard to monitor where these little fish go. So once they have spent about 6 months at sea, that's when they are considered whitebait, and they will start heading up towards our rivers. So they can like smell the fresh water that's coming out from our rivers, and they'll swim towards that. They form big schools, as we may know, and swim up those rivers in those big schools. They have a very low survival rate, unfortunately. As with each stage of this life cycle, you start with big, big numbers, and at each stage it gets smaller and smaller, so that in the end you maybe only have like 1 or 2% of that original eggs actually surviving into adulthood. The whitebait stage, they stay at the lower reaches of the river, so lowland areas, and that's because they're quite small and they can't really climb up too high up the rivers because they're not super strong. Once they've grown up a bit from being whitebait, we consider them to be adult Īnanga. And so they can head possibly slightly further inland. They might be able to climb up the rivers a little bit, but unlike some of the other galaxid species, these guys are really not very strong climbers. So Matt, a little bit later on, has got some videos of some of our other galaxid species which can like scale waterfalls and everything, but Īnanga can't do that. They just hang out in bigger groups down at the bottom of the rivers. And most fish will live to about a year old, and then they'll spawn. So from the time that they hatch to the time that they're an adult is about a year. And so they'll spawn once and then die after they spawn. It is thought that some of these fish can live up to 2 to 3 years and then spawn after that, but we generally find that these fish die after they spawn. There was one site that I was at out in Langholm, where we put some habitat out for these fish to be able to spawn in, and we went out one time, and in amongst the multitudes of Īnanga eggs, we actually found maybe like 5 or 6 of the adults that had done their spawning and then died and got caught up in those bales as well, which was pretty cool to actually see that happen. I'm just going to show you a video of some spawning. This is a spawning event in Northland. You can see the person in the wetsuit ready and waiting to find those fish. So this video would have been taken when there was a spring tide. So the water's coming up even higher. They're sitting in the saline wedge where the freshwater and the saltwater meet. And you can see the little fish under the surface. So here they are swimming up into the grassy banks on either side of the river, and they are wriggling into the grass down into the root mats, so that the females can release all of their eggs, sorry, and the eggs will stick to the blades of grass and the roots down there, so that they can stay there once the adults have gone. The water is really cloudy, and that's because the males are also releasing their milt at the same time so that the eggs are fertilized. You can see quite clearly here how they are wriggling down like right into the root mats of the grass. And that's because if they get further down into those root mats, the eggs are going to be more likely to stay moist and be more protective during the time that they are up on land. Okay, and so as I said, that spawning area for Īnanga is actually quite limited. So we know that they spawn in the saline wedge approximately. So that's where the saltwater and the freshwater meet. And that is a very small portion of rivers generally. Obviously that varies in size depending on how big the river is, but generally quite a small area that they can actually spawn in. These...
Ella, sorry, I'm also just calling 9 minutes now, but keep going, but just to let you know that it's been 9 minutes.
No worries, thank you. So these fish need that saline wedge area, but then they also need all of these other factors to be able to have successful spawning in that different area. So right time of year, right tide levels, right bank and vegetation, all of those mixes, and hopefully we have successful Īnanga spawning. Yep, that's the same thing as there. So we have an ideal bank vegetation. They need to be like densely root covers so that the eggs can survive, and nicely shaded as well so that they don't get hit by the sun, which will dry out the eggs, because then they will not survive. So our Īnanga are really important because they are one of the most prevalent fish species in our freshwater environments. They're really important food source for everything else, and then also protecting these species also helps look after some of the other species in our river. So some of the threats that happen for our Īnanga at various stages of their life cycle are introduced predators. So as it says here, we have slugs and mice can eat the Īnanga eggs, especially while they are up on the banks of the river because they're very vulnerable there. And then we have other fish, both native and introduced, that can harm both our Īnanga and their eggs, as well as their various stages of the life cycle. There are also natural predators, obviously, of Īnanga, like the eels and some of our native birds and whatnot, but these introduced predators are providing more harm to these fish.
Perfect, Ella, I'll just give you 1 more minute if that's okay.
Okay, no worries. In our urban areas, we've got lots of different threats to these fish because of various stages of development, including mowing, changing of banks, and increased sediment, which can all harm these fish, especially in urban areas as well. We also have lots of barriers to movement up and downstream for these fish, but Matt is going to talk about that next, and also how we can help our Īnanga. That's me, Sophie.
Amazing. Thank you so much. And wow, what a cool video that was. That was an incredible video. That was just amazing to kind of see them all wriggling around in there. It was wonderful. Before I introduce Matt, I just wanted to quickly go through a few terms that you may have heard and not be sure of. So spawn, that literally means when the fish release or lay the eggs. So that's what spawning is about. It's just kind of like laying the eggs. Galaxids, I think we mentioned that at the beginning, but just to let you know, it's the collective term for all of those, that kind of species of fish, or not species, is it genus? Matt can tell you more about the specifics of it, but it's the group of fish. So that's like Īnanga, Koaro, giant kōkupu, banded kōkupu, and the other one, short kōkupu. Milt, in case you don't know what that means, that just means fish semen, and that will fertilize the eggs. And I also really quickly wanted to show you this cool educational toy that my friend Beth made, and you open it up, it's the grass, and you open it right up, and I don't know if you can see that, but inside of these little white things that you can pull out, and inside them there's a little fish. How cool is that? So that's one. I just wanted to show you this example of a super cool toy that you can show kids how to find eggs. Anyway, very, very cool. Now I'm going to introduce you to the wonderful Matt Bloxham. So Matt works at Auckland Council, and Matt, I'll hand it over to you to introduce.
G'day, everybody. Really nice to be here tonight, and thanks for the opportunity to talk to you all about Īnanga, and really impressed with the information that we've had from Ella and Sophie. It's all sort of blends together to hopefully give listeners a fairly good grasp on how Īnanga operates and how important they are as a fish species. I'm just going to bring up my presentation here for you. So we've sort of talked about a few of the pressures. Well, Ella did towards the end there, some of the issues for fish, why their spawning success is a bit reduced because of all those impacts on their that really vital and discrete habitat. But there's sort of a whole lot of things, unfortunately, that are at issue for Īnanga and the other whitebait species. They've got so many pressures, and it's for that reason that whitebait as a whole are actually in decline. Only 1 out of 5 species is not threatened with extinction within the Auckland region and nationally also. So quite a big deal. I'm just here tonight to talk about one of those things. Would need a good few hours to talk about all the pressures. So tonight I'm just going to be talking about fish passage and why fish passage is so crucial for this wee guy. So I'm trying to give you a bit of an Auckland context too. I'm assuming a lot of our listeners tonight are from Auckland, and one of the things that categorises Auckland streams is they tend to be really small, and all of our native fish occupy slightly different habitat. They all sort of fit in different parts of the stream. Some are more coastally situated, and some occur way inland. And in terms of describing that, describing that, the native whitebait fishery sort of provides a really good example of how members from the same family. So before we heard the term galaxid mentioned, and that describes the family that the whitebait belong to. And they're called galaxids because the first person that described them looked at their wonderful features, lots of wonderful speckling, and reminded him of the galaxy, and so that's how they got that name. So whitebait occupy all sorts of habitat, runs, riffles, and pools, and the most crucial thing here, and the point I really want to make very clear tonight, is that all those fish need to be able to reach freshwater habitat to complete their life cycle. So they're coming in from the sea and they're trying to reach up into this fresh water to get to their what we call natal habitat, which is the habitat of the origin and where they will rear as adults. And this is what they face in Auckland and elsewhere, huge barriers to migration. And it's not just physical barriers, it can be velocity barriers. It can also be chemical barriers. You can see in that top left-hand image of a stream running through what amounts to a big gutter. Well, streams like that or modified waterways like that heat up enormously. So, you know, contaminants, we think about temperature as a contaminant. That is one of the things that limits them. The other thing that we have to mention too, Sophie and Del have already mentioned just how small they are when they come in. They're not like the salmonids that when they return to freshwater and Northern Hemisphere streams and rivers, big adults that can actually jump past obstacles. Our native fish are really small. Typically, they haven't even started feeding yet, and they've got very limited powers of you know, very limited energy to actually reach upstream. So some of our native fish can climb, others can't. Those that can climb are, you know, capable of incredible feats. You know, I've found cockapoo above 20-metre waterfalls before, and I'm just about to show you a video in a couple of seconds' time of how they managed to do that. But we've already sort of we've already talked about some of the species, and tonight I'm just starting with the fish species that are the most amazing climbers. We start with Kawaro, they're the most adept at climbing, and then you have banded cockapoo, which is a species that is quite common in Auckland, one of the few species that is. Short-jaw cockapoo are reasonable climbers, they'll extend a reasonable way inland. Giant cockapoo, not so much. They tend to be more of a sort of a coastal wetland dweller. One of our largest whitebait species. These guys have been recorded getting up to about 600 mils or 60 centimetres. So, you know, really large fish. Not many people realise that when they sort of throw back another whitebait paddy. And then finally, we have Īnanga, which unfortunately have very limited powers of migration. These guys, they have no ability to climb as the other species do. The only way they can reach upstream habitat is by swimming and swimming alone. And so we've already looked at this issue of you know, just how threatened these species are. So I'm not going to dwell upon that. So I just wanted to show you this video because a video sort of tells it, you know, it tells the story better than any words can. And just before I start it, you'll see there are two types of fish species that are trying to get past this phenomenal barrier. And you'll see just how bad it is in a second. And you'll see initially Īnanga trying to climb up. And I'm going to start the video now. And you can sort of see them circulating there downstream of this barrier. And then as we move further up towards this formidable vertical surface, you can actually see them having a good old go at getting up it. And, you know, these guys have you know, quite lucky because the water is well oxygenated. So there's plenty of oxygen for them to utilize, but that alone can't power them up. And you'll see them, I don't know whether you can see my cursor, but you can actually see them trying to slither their way up, power their way up, and they'll get a few centimeters out of the water and then just fall back. And that's about as far as they'll get.
Just to let you know, Matt, we can see your cursor, so feel free to
Oh, good.
To move
thanks.
Yeah.
Gee, I thought I'd overdone it time-wise, so that gave me a big fright, Sophie. So now we're going to move over to the left, and here you'll see banded cockapoo. So banded cockapoo, you'll see them just slithering up past that wee pipe outlet, have incredible physiological adaptations that allow them to cling on to along to that vertical surface and make it up to the top. Unfortunately, we don't see this, but when they get up to the top, it's a very sharp edge. They don't get any further than that, unfortunately. And look, I just want to show you this other wee video. This is from a wee stream. Oh, gee, a wee stream called Pataroa Stream. And here, unfortunately, the poor old fish have very little oxygen because the downstream environment is just so badly degraded. So here, the weir isn't very high. It's only about 30 centimeters high, and the fish really struggle to even get their heads out of the water. So I think those videos tell the story really well. So I just wanted to touch upon it, what it is about the structures we create in streams become such a barrier for fish. And you can see on the left-hand side a culvert that may have once, when it was first installed, may have once been flooded and allowed decent fish passage, but now you can see that it is perched, and not only perched, but you can see that the abutment that holds the culvert in place is also caved away. So there are two issues here. First, the water actually free falls into the pool below, and secondly, there's a big overhang. So there's no way the fish can get into that culvert. It's, you couldn't wish for a more perfect barrier. And on the right, you can see sort of much the same. Here, it's more a velocity issue that's preventing the fish from actually being able to get through. We also have things like floodgates, and floodgates are designed to actually close as the tide changes. So the fish would be powering up the stream, using that sort of tidal water to propel them further upstream. But when they reach the floodgate, the floodgates are closed. On the right-hand side, we have a weir, which the fish will never be able to get up because of that overhang. Fish can't climb upside down. They're pretty amazing. Even the climbers are amazing, but they're not going to get past anything like that. So all sorts of issues for fish to face. I've got a couple of case studies for you tonight, and one of the case studies I wanted to show you is this nice one of where rehabilitating fish passage to benefit Īnanga also benefits other endangered species. In this case, it's the endangered fairy tern, a bird species that is down to 35 individuals left in the wild. They had a good breeding season this year, but they're certainly not out of danger. And so these guys rely upon, I'm going to show you the map. So this is where the barrier is, where the red pointer is. And what happens is the fish, the Īnanga, come up from the sea, follow the stream up, and would proceed under this road up to these lakes, which is where they feed as adults. And it's here that the fairy tern would feed on them. But unfortunately, they can't, because there's this terrible perched culvert. You can see there's a big drop from the culvert, and I'll just play a very short clip that gives you a bit of a feeling for what they have to encounter. The water's free falling to the stream below. There's no way they can get past that. So we went to the authorities, in this case, Auckland Transport and NZTA, and said, look, we need this culvert replaced. Initially, they said no, they didn't have the budget for it, nor the mandate. So initially what we did was we installed this fish ladder, and you can see this is a pretty chunky stainless steel fish ladder on the right, and through the culvert, in order to try and dampen the flow velocities, we installed these baffles and spat ropes that run all the way through. Now, in less than 6 months, you can see how much the ladder has actually become blocked by vegetation and sediment. And one thing that you can't quite see, you can just see it at the bottom. One of the problems with ladders and just installing culverts with ladders is the thing that actually creates the perch in the first place is always scar. And it's during those really big flow events that the worst scarring happens. And so if all we do is install fish ladders, but don't properly protect the stream bed from scarring and falling away even further, we get a situation like this. This is a fish ladder that was installed by an old colleague, a chap called Charlie Mitchell. This is in the Puhanui. And you can see that where once the fish ladder was sort of submerged, now it sort of free falls down the stream below. So nowhere they can get into that. So here we have to look at sort of different options. It's just a wee graph that I've created here, which shows some scar protection beneath the culvert. And another thing we can sometimes do, if you can see up where my cursor is a bit further downstream, sometimes what we can do is we can actually hike the water level up a wee bit by creating a tailwater control, which basically just, lifts the water level a bit and tries to back flood through the culvert.
Sorry, I'm just giving you a time update, so maybe about another 3 or 4 minutes.
Okay, thank you. Thanks so much. So here we see an example of a fish ladder that in less than 3 or 4 years has completely failed because of issues with scar issues. And this is a pretty extreme example, but it just shows the sorts of issues that we face. So going back to that Te Arai example with a ferry turn, what we thought we'd better do is we'd better sort of do some validation monitoring, which is just going back to see whether or not the fish ladder that we'd installed was doing anything positive for the fish and getting them through that culvert. So we placed lots of nets upstream and down of the culvert. And here you can see some of the catches from downstream of the culvert. The results were a wee bit depressing, really. You can see that, don't worry about those, the fish on the right-hand side of that table. That's Gambusia. It's a non-diatomous fish species. They're a pest fish. The ones to concentrate on are the fish on the left. And you can see there's a number of Īnanga. Most of them actually were found directly beneath the culvert. They couldn't get through, just 2 adult Īnanga that were able to get through before that culvert, that fish ladder started to, the stream started to degrade down. So not a great result. And one we're not very proud of. The really great news is that through constant badgering, AT and NZTA have finally offered to replace that culvert outright because of its significance to ferry turn. And you can see it's a major exercise, really costly. In this case, it's unfortunately because of difficulties with the ground. It's we're looking at a huge cost there. But and this is the sort of culvert we would hope would be installed here, one that has sort of banks on the inside of the culvert, one that where the bottom of the culvert is embedded, so the stream, the culvert fills with substrate. All we're trying to do is simulate the environment, the upstream and downstream environment through the culvert in terms of the bed material and in terms of the flow conditions. And so you can see this. This is sort of a best case scenario. We also have all these jolly weirs in Auckland and elsewhere, and this is a gauging weir, and you can see the water's flowing out through a V-notch. You imagine a wee Īnanga trying to get itself through that. One of the worst fish passage barriers you will come across. So one of the things that Auckland Council has been doing is scoping around for some of these redundant weir structures to see whether or not we can remove them and reinstate fish passage. This is actually one out on, this is one of the first weirs I removed, actually one of the only weirs actually, and this is out on Great Barrier Island, and this was brought to our attention by somebody from the local community, and we managed through quite a lot of toil to remove that culvert. So there's the before and after. So there's before the culvert was removed, and this in a few weeks afterwards, you'd hardly even know it was there. So we've managed to reinstate the fish passage there. There are plenty of other weirs in Auckland we're trying to remove, but unfortunately some of them are sort of valued by the community for reasons other than the ecology, and so we're struggling a bit with those. Sophie wanted me to talk with you a wee bit about some of the approaches for restoring habitat for Īnanga. I just wanted to use this Waipururu stream as an example. This is an amazing wee stream that flows down through the Simon Cemetery graveyard that not many of you will have visited. It's a bit spooky down there at night, but it's an amazing wee stream, and it runs right out to the coast via this huge underground culvert. And despite that, we managed to find an eel and a couple of banded kōkupū in there, much to our surprise. So one of the key things that we must do when trying to recreate habitat for any particular fish species is actually identify the bottlenecks for recovery. And in many cases, it'll be just habitat limitation. There isn't enough habitat. And so so a lot of our focus has been on trying to improve habitat. So this is this wee stream and just below the cemetery there. And here, because the fish species we're trying to create habitat for are pool dwelling species, i.e. banded kōkupū and eels, we're setting about installing these cross veins, or these basically logs that are placed and anchored in the stream banks to actually try and create this structure and channel diversity for these fish. Īnanga, and here's another example of a cross log, and you can see what happens is the water comes down, it flows over the log and creates this lovely wee localized area of scar. So it creates the pool habitat that wouldn't otherwise exist in our soft bottom streams.
Sorry, Matt, I'm just going to give you a 1 minute one because I know there's just so much stuff and heaps of questions coming.
Yeah, I'm just about there actually. I'm just about there. There go those logs going in. And that's after we've planted it up to try and create these nice wee sort of ecological sort of hotspots for Banda Kōkapu. Īnanga are sort of a different fish species, as I mentioned before. They really like run habitat and they really like trailing edge cover. So this is the kind of habitat, if you were keen to create habitat for Īnanga in a local stream, this is the kind of cover you would try and create. So on the left, you've got this lovely overhanging, this is kauri grass on the true left bank, and on the right bank, you've got this fantastic root structure that creates these wonderful stable bank undercuts for all manner of species. Īnanga love them, eels love them, all the Kōkapu species love them, bullies love them. You can't go wrong by sort of planting ferns and tree species as close to the channel edge as you can to create those lovely stable bank undercuts. So I'll leave it there tonight, but thanks again for the opportunity to talk. Thank you.
Great, thank you so much, Matt. Fascinating and so amazing to see, that fish are persisting in these pretty crazy environments. I'll just get you to stop sharing if you don't mind as well. Yeah, it's amazing to see where these native fish can persist. Now, just a couple of words. I'm just very aware that some of you may not be scientists. So salmonids that Matt's talking about, salmon is an example of that. So he was talking about that the adults come up the stream, unlike, say, whitebait where the juveniles come up. Spat ropes just refers to the mussel spat rope, so fish can climb up on those. Scouring, I think it was kind of obvious that it was talking about the water rushing and caving out that space. And diadromys is your word of the day, which is a fish that migrates between fresh and salt water. So that's a lot of our fish in Aotearoa. And when he was talking about bullies in the stream, he wasn't talking about an unpleasant person. That's another type of native fish. Right, you're doing really well, and I know it's a lot of information. My slide is just going to have quite a lot of pictures, and I'm going to be talking about some of the solutions. And then we'll get to a lovely Q&A, and we've had lots of really cool questions coming through already. Sorry, I'm just going to figure out how to do that. There we go. We've had lots of really great questions coming through. Any question? There's no such thing as a silly question, and if you're curious, it's really great. This is me presenting about Puna Manaaki Īnanga, and this is an example of one of the schools that I've been working with, Royal Road School, who have helped to put in a fence and do some lobbying and paint some cool Īnanga like this to go on the fence. So I'll show you a little bit more about that in a sec. So as we've heard, there's quite a few wee threats that the old Īnanga are facing. So we've heard about habitat, poor quality water, streams into pipes, and the dams and weir. As Matt was talking about, this is actually Matt's legs. We went and saw this weir, which is hopefully getting removed, which is really exciting. Grazing the edge of rivers or mowing the banks where there's nice grasses where Īnanga can spawn. The pest species, which gobble up those eggs that Ella mentioned. And the whitebait fishery. And down here, this little sad 3 pictures was at a stream in Te Atatū, and it had some kind of a pollution in it and had stripped all the oxygen out, and I found a number of dead fish, including Īnanga, so that was really sad. So that's kind of what you're battling with in the urban environment. So history of the project, our rivers are getting sick, we're wondering how our native fish are doing. We focused on Īnanga, and we found what Ella refers to. We want to find the love zone, or the area where those fish spawn or lay their eggs. So in 2017, 2018, Matt actually helped Community Waitākere do some spawning and some searching, and have a little look for some spawning sites. And we found 6 sites across Auckland based on how likely they would be spawning there and how much community involvement we could have. So we've got one at Epping Esplanade in Henderson, one at the Paramuka Stream, one at Pixie Stream behind the Te Atatū Roosters League Club, one at Lotherhurst Reserve, one in Moira Park, and one at Gill Ave, which was a former rubbish dump. And it was pretty gross working there, to be honest. We got rid of that one pretty soon because I got all itchy when I was looking for eggs, and there was some kind of yucky stuff that kept turning up at that site. So problem number one, pest monitoring. Introduce predators, and the solution is pest monitoring and trapping. This is a little image of this display that was made showing a naughty little rodent coming along and feasting on those Īnanga eggs. And here's an example of what the Īnanga eggs look like. That's a finger, so you can see how tiny they are. But they're in the roots of these grasses, and they're accessible at low tide. So you can see that they make a delicious treat. So as we've heard, average size adult female will lay 2,000 to 3,000, but only about 11% survive to hatch. So they're getting predated upon, and it's getting worse because we've got a whole lot of introduced species. So the solution is, let's see what's out there. So we put out a bunch of monitoring cards, which I believe there's a photo in here actually of them. Nope. Okay, sorry, I thought it was. Well, monitoring cards are the things that you fold open, and they've got black ink, and you put peanut butter in the middle. And then what happens is you leave them out at night time, and a hungry little creature sniffs, comes along to eat the peanut butter, and then leaves their footprints. And you can do a whole cool pest detective thing and see if you've got an issue with rats, mites, or hedgehogs or anything. And as you can see, this is at Pixie Stream. The first or second trap, nothing. All around the Īnanga spawning area, we have quite a high density of mice and hedgehogs. So we need to be like targeting that area before spawning season, ideally all the time, but before spawning season to ensure that those eggs have a really good chance. So if we find eggs at a spawning site, we then do the pest monitoring, and then at the moment we're working with Auckland Council to get trapping in place kind of permanently, and that's part, Matt's been lobbying for that, so that's really great. Thank you, Matt. Lack of spawning areas. Solution is, let's protect the spawning areas. So this is a letter from Royal Road School saying how we need you guys from the local board to allow us kids to build a fence and bring awareness to everyone in order to save and protect the species. So the council have been, the local board have been really supportive. We started off with this just makeshift fence. This is at Moira Park or Manutawhau, and lots of dogs race in and out of here and go swimming. So this is the only spawning spot on this whole stream. And so this is where we've found eggs as well. So we really wanted to protect it. So we've made a wee sign, stuck some of these fish that Royal Road School made. And we've got an even cooler fence now because the council have been really good at helping us. So they've put up this proper metal fence, although you can see that there's a couple of bars missing because people like to kick down fence palings apparently. And this is another school called Lincoln Heights School. And they made these really cool signs to go in Lotherhurst Reserve. That's a very earnest and cute signs, but they came up with some good phrases. Keep your legs off the eggs, and no eggs, no Īnanga. So that was quite a fun little exercise that we did with them. What else have we got? Education, a huge component. Obviously, there's people like you guys who are coming along tonight who might be learning about it for the first time. It's quite hard to translate some of the stuff into action, but here's an example of 10 things that you or your school or your community or your household can do. Things like planting trees along the riverways and just anywhere that would soak up stormwater, because when it rains in Auckland, a lot of water goes down the stormwater drains, those drains you see on roads, and straight into the river, and it's not filtered. So any way that we can capture that rain or stop it getting into the stormwater drains, that's a really great thing. A big one that we always tell people, and we kind of don't think about it, is wash your car in the grass. I know you may be using eco, kind of like dishwashing liquid or whatever, but it's still a whole lot of things like phosphates going into our river systems. And our rivers are not designed for car wash or soap. So yeah, that's something easy you can do, or you can go to an actual professional car wash place because they collect their water. Otherwise, again, it's just going onto the street, down the drains, and straight into the river. And that can have a really negative effect, particularly on the skin of fish. And Matt or Ayla can correct me later, but I believe that it burns their skin and can be really nasty for fish. A couple of other things in there: collect your roof rainwater. You can get involved with PTS. You could become an urban planner and engineer. And you can always call the pollution hotline if you see something dodgy going on and you're at a stream. So that's just a normal council number. So really advocate for that as well. Another educational event we've had is Freshwater Frenzy, which was last year we had one, and we also had one in 2019, but last year's one was quite a fun and cool event. And we had over 300 people with around 8 organisations. So we had people fishing out the rubbish from a stream with Auckland Libraries. We had Īnanga here, and that Paul had caught from the Pixie stream, and Laura from Whitebait Connection was there supporting it. We had tuna or eels for kids to see up close. We had a big sort of eel sculpture that had been made like a community art project, and here's some beautiful Īnanga close up in the tank. So it's a really good opportunity for people to come, learn about the stream, see creatures in the stream, because lots of people are like, whoa, there's fish that live in the stream, or these bugs. Often you look at places and you just think, oh, that's Manaaki water going through a pipe. But believe me, native fish are so resilient, it's crazy the places that they will survive and they'll continue to persist. Here, that's an example of those monitoring cards that I was talking about. So you can see there's footprints across there. Other things that we do is we do water quality testing. So we do temperature, we do pH, and we do little tests like phosphates. So they're like quite easy to do with schools. So that's through a Waitakere kit, and you can do that with your project twin streams. We do pest monitoring. We look at what's the kai of the Īnanga. So we look at the insects that live in the stream, and we do planting along river edges, and we use really cool toys like this, which is a cute little Īnanga fish. And the awesome grass toy, which I was kind of hoping that you could see it a bit better now, but if you look inside there, you can see those little white eggs that you can pull out, and there's also some examples of tiny wee eggs over here, those little 3 eggs there. So this is a super cute toy that was made for us by my talented friend Beth. So if you want her to make you some educational toys, I'm sure you can get her details off them. What are the successes from that whole project? We found eggs in 4 sites. And again, remember they lay between 1,000 to 3,000 eggs. And sometimes you're going along and seeing this. I mean, you can count them. There's probably about 10. So something is getting to them, something is eating them. And, you know, it's kind of slim pickings from the beginning, which is why we need to do things like pest trapping and all of those other things. We found Īnanga in all 6 sites. And we are actively protecting 2 spawning areas, so that one with the fence and then another one in Lotherhurst Reserve, and we've planted up 4 areas, and this is the weir that I mentioned before, which is slated for removal. As you can see, this is the point where they'd have to swim over, and it's a lot of velocity, so hopefully that happens. And I think that brings us to our Q&A. So I'm just going to stop sharing and bring in my lovely panelists. Nice to start video. Great. Okay, Matt, sorry, I just need you to start your video. Voila. Okay, welcome back, guys. So I've got a bunch of questions from people, and we can just kind of take it in turns, sort of chipping in and answering these. So we'll start from the beginning. One question is, are there any studies about proving the Īnanga numbers improved by hay bale artificial habitat? And for people who don't know about that, basically you can get a straw bale and put it in place of those grasses, and Īnanga supposedly wriggle and lay their eggs. So I know that Whitebait Connection's done a bunch of that, and Matt, I don't know if you've got anything to say about that, but I'll pass that one over.
Yeah, I think in terms of scientific studies, I know an old university friend who is now a lecturer down at Canterbury University. He's done a lot of work down there, and they've used all sorts of different substrates to try and aggregate fish and get them to spawn in habitats. You know, one of the things they're doing with that, and I know Ella and Kim and others and Laura have used hay bales from time to time is to try and stimulate spawning where the conditions don't already provide for it. So it's just a way of sort of trying to re-trigger that spawning. So I think that most of the research has been done down in Canterbury, looking at using core matting, and I think they probably use hay bales down there. But yeah, I can't, to be honest, I'm not entirely sure what the results were, other than to say, in terms of whitebait survival, in terms of how many fish it produced and how many of those fish returned from the ocean. That's sort of quite a big study, but what it did show was that these artificial substrates are incredibly important, incredibly successful, I should say, at providing habitat where none exists presently. We don't want to just rely on artificial media like that. We really want to create habitat, natural habitat that will sort of last forever and replace itself. So it can only ever be a sort of a temporary solution. Yeah.
Yeah. What are you finding, Ella, with your work in that space?
For the work that I personally have done, we have found that the bales in here can provide, as Matt said, a really easy way for us to see and provide more spawning habitat, so space where those eggs can stay above ground safely for about a month. Being able to link the those safe eggs to actual adult Īnanga coming back up the stream is nigh on impossible, because they do go and spend that time out in the sea, and so we have no idea how many of the fish that were born in that stream come back to that same stream. So we can only hope to improve the habitat for each stage, or as much of the Īnanga life cycle as we can, and then increase their numbers at all points in their life cycle if possible.
One of the big things that I don't know any of us have touched upon just yet, but Ella just referred to the marine phase where the larvae are off out at sea and they're sort of subject to all sorts of predation pressures and all sorts of things. And the return rates, the number of larvae that are actually coming back into freshwater is actually really small. Like it's only on average between 1% and 2%. So if what you have in the spawning ground is just a few fish being able to spawn because there's not much habitat, and of those fish that spawn, 99% of the eggs get eaten, such as you showed with that incredibly grisly slide there, Sophie, with just a few eggs, then it translates that, very few fish larvae are going to go to sea, and even fewer are going to come back. So, there's a lot of, there's huge obligation for us to actually try and make sure they succeed at their spawning time. If we can actually ensure that hundreds of thousands of eggs are going to sea as larvae rather than just a handful, then we'll make quite a big difference to the fish, to the whitebait fishery.
I've just got a really quick question here, Matt, in terms of Laura's just asking what were the roots of that tree species in your last slide?
I think they were mainly kakatea, but there's a lot of tree species that produce those wonderful stable bank undercuts. The trees that I most like are trees like mahoi, nikau. A lot of the wonderful fibrous tree fern species produce these wonderful stable bank undercuts too. The only problem with a lot of those species is they require sort of initial shelter, but once you get that shelter in there, you can come in with those tree species, and I sort of recommend planting those tree species as close to the stream edge as you can to allow those roots to propagate out into the stream and to create those lovely stable bank undercuts. It's like sort of creating underwater caves really, and it's into those wee sort of concavities that the fish go time after time when there's a huge flood. So that's how they survive big floods, such as we had recently in Auckland, by going under the bank.
Okay, we've got probably quite a few questions. So this question, I'll just get you to Matt, maybe pass this over to you, but just answer it quickly if you can. So is there any way you can tell a male from a female? Is there a temperature swing for when they become boys or girls like tuatara, or do we know if they're affected by a contaminant?
Yeah, I don't know the answer to that. I saw Pregnan's question come up. It is a good question. It's probably one that can be answered because we're very fortunate that some very dedicated souls are now sort of breeding these fish in captivity to try and help us create new populations or replenish old populations. They could probably tell you that, but I couldn't, unfortunately, on this occasion.
That's all good. Now, I've got one here which says, from a Te Ao Māori perspective, when you see the natural predators, does that mean that the habitat is good and the fish are running? Well, we probably can't provide a Te Ao Māori perspective, but I know that from personally, and I'm sure that you guys, Ella and Matt, might have some thoughts on this, but there are key species that are things like indicator species, which can show us the kind of like predictors of how healthy an environment is. That might be things like coda or the freshwater crayfish, some of the more sensitive native fish. There are certain types of macroinvertebrates or insects that live in the stream that can indicate the quality of a stream. Do you guys have anything to add to that?
All I would say is, and Ella touched on it in her presentation, in an evolutionary sense, most of the pressure for whitebait came from the water and not from the land. I mean, there were the banded rails and the weka and crabs and quite a number of terrestrial animals that bird species that would have fed on them, but most of the pressure was from the water. So things like tuna and kahawai all feed on Īnanga eggs and on the adults. But now, of course, we have so many more land-based predators. And so if those eggs are high and dry for between 1 and 2 months, and if a mouse or a rat or a hedgehog or anything like that finds the eggs, they can actually just sort of chew away on those eggs at their leisure. They've got sort of a whole month to actually have a go at them. So you can understand that massive pressure from predators that weren't here originally, and that's what we're having to deal with.
I just wanted to quickly show you guys this. Oh goodness, this women fading out thing. It's called the Waitakere Invertebrate Field Guide. It's a really good resource for teachers. You probably can't see that too well, but you can see that there's these boxes with little creatures in it, and in the corner they have a different colour. So some of them have green, some of them have orange, and that's about these bugs being sensitive to different levels of pollution. And so if you have a bug with lots of green bugs, things like your mayflies, etc., that's kind of indicating that your different qualities of your river, so that it might be higher in oxygen or a bit cooler, which is kind of things that we consider, like a healthy stream, because obviously in the cities it's not as cold because you don't have trees everywhere and there's not as much oxygen for various reasons. So yeah, that's a really good resource if anyone's a teacher to look up Waitakere. They have a bunch of resources that you can download, and there's also a Waitakere testing kit similar to the SCHMAK, SCHMAK kit by NIWA. So those are kind of two informal testing kits which you could get your hands on. And if you want any more information, just type that in the questions. All right, what else have we got? We've got another interesting question. How big of an issue is climate change, hot weather, extreme rainfall events? Well, I can talk a little bit about, I went to, and then I'll hand it over to you guys, but I went to this talk last year during lockdown about taonga species and climate change. So that was talking about tuna, Īnanga, any species that's a taonga really. But one thing that they did mention was that we were looking at, depending on the temperature estimations for your area, there was a lot of higher autumnal temperatures. So the time when Īnanga are laying, it could be a lot drier, which means that the eggs will be less viable, they might dry out. That was one of the key things I noticed that I remember. And also that with rising sea level, the spawning areas may change. So if you're going to invest a lot of time and money, etc. in these spawning areas, it's great for now, but maybe in 20, 30 years, you might have to kind of redo the kind of testing to figure out where the spawning area is.
Yeah, that's a really good one to touch upon, and we're already actually seeing examples within the Waitamata of saline water that is actually coming into sort of pre-existing freshwater wetlands and sort of changing them around a wee bit. So we're getting sort of more saline vegetation establishing in areas where previously there was freshwater vegetation. So there will be sort of a period of transition, and the hope is that there's enough plasticity in the breeding cycle of those native fish species to be able to cope with that change and sort of to move to those different areas. We hope there is, but we're not 100% sure. Probably more of a concern actually is the impact of climate change on sort of oceanic currents and how that might change the way larvae circulate off the shore. Some of the species we think stay quite close to shore, but there are other native fish species such as tuna which sort of spawn over way out in the Tongan Trench, and so for those larvae to find them their way back passively to New Zealand waters is it's big question marks over.
And I guess rising sea levels as well, and like stored methane. We don't really know how any of that stuff's going to kind of. No,
there's lots of things that we just suck it and see really, and just hope that we can future-proof these environments as much as we can by protecting wetlands and just allowing them to transition, not get too caught up and trying to prevent sort of that saline intrusion, just to let things happen. Nature will sort itself out.
Ella, I don't know if you've got anything to add in that, otherwise we can go on to another cue.
No, I think you guys had some awesome answers there.
Perfect. And actually, I have a question for you, Matt, since you always teach me interesting things. So wetlands, as you just mentioned, for those of you who don't know, wetlands are basically endangered species, and there's only about probably less than 10% nationally, and they think in Auckland less than 5% of the original wetlands. The rest of them have been drained. You mentioned not knowing that much about giant kōkupū's spawning areas. How are they going, and what are we finding out about where they spawn? Do we know that they spawn in wetlands? What role do the wetlands play? Can kōkupūs spawn in other areas?
Yeah, so the kōkupū species generally tend to spawn adjacent to the adult habitat, whereas the Īnanga will tend to come downstream to that all-important sort of saline wedge that Ella referred to earlier. Kōkupū tend to actually use, they tend to spawn next to the adult habitat. So they don't have the incoming tide to actually help propel them up into the vegetation, to get them up into that vegetation. What they rely on is floodwaters to actually propel them up into those areas. And so for giant kōkupū and short-tailed kōkupū and banders to be successful, there needs to be not only a flood to occur within that spawning period when they're all sort of fertile and ready to go, but once the eggs are actually up in that streamside vegetation, there then has to be a return event of a similar magnitude within the next 1 to 2 months. So that doesn't happen, then those eggs will just remain high and dry, and sometimes it doesn't. The only thing that kōkupū species have got going for them is that they tend to be a bit longer lived, so they can sort of survive with occasional lack of recruitment because of massive spawning failure, whereas Īnanga don't have that. They only live for, as Ella mentioned, for between 1 to 2 years. So Īnanga have the comfort of knowing that that they'll always get that next big spring tide, but kōkupū don't.
Very interesting. We've got another question, which is talking about could we help populations by breeding in captivity and releasing those? That has been done in addition to habitat restoration. And before we answer that, I just wanted to show you this document, which was taken from a couple of freshwater ecologists. But basically, this kind of paragraph down the bottom, a whitebait fritter, a cup of whitebait, 500 fish, would take 650,000 eggs to make a fritter. So that's quite a lot of eggs when you think about it. And when you think back to that pitiful picture of the mere 6 eggs from the 2000. There are some places I know where you can get whitebait that has been sustainably farmed, and one example is this place called Manaaki, which is at the Matakana markets, if anyone's been up there. So they do it all in the lab. This is their website, and you can buy a little bit of you can buy stuff from them. But Ella or Matt, do either of you know anyone else that's kind of breeding them and releasing, and did Doc do that, or where are the fish going that are being released, and do they have success?
It's still, do you want me to answer that, Ella?
I was just going to say I only know of Manaaki, and their focus is on giant kōkapu, because Lynn, who works at Manaaki, has said that breeding Īnanga in captivity is really hard because of their short life cycle. They're not as like hardy as the giant kōkapu are that are longer lived as well.
Yeah, so so there's Manaaki, and you know, they're actually breeding giant kōkapu for the whitebait trade, but in the process they have been very good to us, and they've they're also allowing some of those fish to be released. They're also
sorry, when you say the whitebait trade, you mean in order as in
for premium whitebait. So variously known as New Zealand premium whitebait. So they supply giant kōkapu whitebait for the restaurant trade, and you might think, well, that's very odd. You know, it's an endangered fish species, and in some respects it is. But in the process of doing that, you know, they're producing more than enough fish to also provide us with fish to actually re-release, repatriate back into former ranges that have been degraded for various reasons. And it's that whole issue of breeding fish for release is highly contentious, and a lot of freshwater ecologists who are very sort of down on it, I would say, and for good reason in some cases. But one of the most important things is that if you do this, it's really important that rather than throwing fish into environments that are heavily degraded, everything must be done to actually try and improve the ability of those fish to survive in those habitats. So we're talking stream restoration, trying to improve water quality, reduce sediment, all those different things that will actually give those fry a fighting chance when released. In addition to Manaaki, there's also another wonderful couple of people, Jerry Lees Webb and Lynn Hamilton Hunter, that operate a fantastic hatchery on the edge of the Kaipara, and they're actually breeding giant kōkapu just for the purposes of restoration. And so I have no idea how they managed to do it. It's financially, it must be disastrous for them, but they're incredibly devoted people, and and they're actually helping us with a lot of the work we're doing. Manaaki are also helping us breed short jaw kōkapu for release into
some. That's exciting.
Yes, there's some really. I personally believe there's a need for it, simply because we talked about that lack of recruitment, lack of larvae coming back into streams. If there are very few larvae, you can improve a stream, make it into the gold card standard. But if there are no larvae coming in from the ocean, then you're creating an empty motel, basically.
And how can you tell if those translocations or the moving of fish from one place to another, how can you tell if they're effective? Do you just kind of go back and go a torch at night time and do a bit of a count, or you're catching them, or?
Yeah, so the ultimate aim is to actually achieve a sustainable, self-sustaining population. It's one thing to actually release fish into a stream and have them survive there, and if you've managed to do that, then that's a major success. If, however, you manage to actually produce a population that is of a size and healthy enough that they actually start to breed, and then you get recruitment back in from the ocean, then you've really hit the jackpot. And but we've just lost so many populations, particularly of giant kōkapu in Auckland, that you can't rely on doing that in just one stream. You've actually got to build sort of clusters of streams that together are chucking enough larvae out into the ocean to help get those fish back.
So just got about just under 10 minutes and there's 3 unanswered questions. So thank you so much to everyone who sent through those, and we'll quickly go through that. Just before I answer, or we answer these questions, there's a comment on here, what are those scars made of? And I'm not sure if you mean the scours, but if you want a bit more clarification on that, then just type it in. But the scouring, as I said, was just that when the water speeds out of those pipes and then kind of digs out almost the bottom and makes it deeper, which we saw in Matt's slide. So hopefully that answers your question. Okay, so she's from Ōtautahi, Christchurch, and wondering how the awa pollution and poor health impacts the health of whitebait, which I guess we've touched on, but maybe it might be worth kind of specifying things like what's the actual impact of things like reduced dissolved oxygen, or some of those nitrates and phosphates.
Yeah, well, there's a whole lot of contaminants that potentially impact not just whitebait species, all fish species, anything that relies on breathing dissolved oxygen. And lack of dissolved oxygen is one thing. So if you did one thing to actually help your stream, it would be to actually shade that stream, because the cooler the stream is, the more dissolved oxygen it can hold. And the other interesting thing is that warm water not only holds less oxygen, but actually also makes it harder for that fish to extract the oxygen. So, shading your stream makes such a big difference. And we need to start thinking about temperature as a contaminant, because unfortunately it is a contaminant in so many of our streams, where streams that sort of go much higher than 20, 22 degrees, getting some of our streams getting up at 26 degrees in the height of summer, makes it really hard for fish to survive.
I guess as well, and Matt, with that point, if you're thinking, oh great, I'll put 2 or 3 plants outside over my stream at home, these areas need to be consistent. So you almost want to start from the top nearest the mountain and come down, because I think you have to have consistent shading for like a kilometre for the temperature drop or something like that. Anyway, you need to have that consistent shade for more than kind of 20 metres or something.
Yeah, you do. And, ideally you'd start from upstream, but you don't always have that ability, So any shade is better than none. And, it's creating more than just shade. It's also, providing a source of animals for the kōkpū to feed on. It's providing, that wood input to for the invertebrates to cling to, and which the fish feed on. It's creating all sorts of structure. Also showed there was that question that you just mentioned about scar, and I wonder whether that question related more to how you actually create those scar pools that fish can live in, and that's just by sort of installing those logs in your stream, so that when the water flows over those logs, you create these nice wee localized areas of scar. So you create really nice depth variation that those fish can use that might not exist. So but there are lots of other contaminants. Sediment is another huge contaminant. So many of our streams have really high sediment levels that may even prevent fish even wanting to go up those streams as juveniles. And
someone told me once that heaps of sediment in the water is basically like a fish having an asthma attack, because they can't quite breathe through their gills. So that's kind of a good one when you're working with kids, asking who's got asthma, or adults, asking who's got asthma, and then kind of saying like, well, that's what it's like for a stream. And Ella, I don't know if you want to talk about how sediment gets into a stream, or how you can sort of stop it, or
so kind of linking together 2 questions regarding Ōtautahi. Like, there are obviously various types of pollution that can affect our streams. As you say, sediment is one of them, and that can be from all sorts of development which is happening across New Zealand, and from lots of like building developments and things, but can also be from farms where there's lots of uncovered areas, and then bringing that sediment down into the rivers and big rain events or flooding events or something like that, brings that sediment down into the water. So that's just like dirt into the water, makes the water super cloudy. As Sophie said, that can really impact the levels of the amount that fish can breathe. If it's long-term sediment, it can also create more shading in the stream, so that creatures that were once on the bottom of the stream can't survive because they don't have as much or any light. And then kind of linking that down to a question from Abbas, which was the what are the effects of sediment accumulation on spawning areas, which is a very relevant question because it's absolutely something that we can see happening. So in those spawning areas, one effect that sediment can have is that it can like clog up the grass. So there's actually no space for the fish to lay their eggs. And so those eggs are less likely to survive if they have to be laid higher in the grass. And another effect is that the sediment can kind of smother those eggs as well, which can mean that they can't breathe, they can't get the oxygen, even though they're above the surface of the water, they still need to be able to stay moist and be able to oxygenate themselves to survive for that time above water.
Well, okay,
Yeah,
so
that's
Jasmine's question, the recent floods, Matt, your thoughts on, or Ella, like, I'm just thinking, oh goodness, I hope all those spawning sites are okay. Like, should we be going back there and like checking that they're not completely clogged up with, excuse my French, but crap from the flooding? What do we do about that? I didn't kind of think about that because they might have like transported a whole lot of sediment and stuff down the river and maybe it really affected those areas.
Well, I mean, I suppose it's unlikely that you know the Īnanga would have spawned by now, and I mean the great thing about grass, particularly some of the native grasses, is when you have those really big events, what they do is they layer up on top of each other, so they actually help armour the stream bank below, and you know, no sooner have the floodwaters subsided that they start, you know, standing up again, and so not much we can do about any latent sediment that is hanging around in the grass now, but the hope is that that grass will recover in time for the spawning period, which tends to be April, May. But yeah, I mean the answer, of course, is to try and reduce the amount of sediment getting to your stream from upstream areas, and just to make sure that your spawning areas have a really, you know, really lush and thick sward and grass species that can cope with.
One more thing on that is that the type of plants that are on the banks, so if the banks are unstable and then there are floods, then those banks can be like taken away, and that can reduce the amount of spawning area, especially if there's like some certain type of plants planted on those edges that will kind of clump up and then bring away huge amounts of dirt out into the river, and taking away those riverbanks takes away habitat and can also like clog up the rivers further downstream.
Goodness me, our fishies, eh? Sorry,
absolutely. You know, those it's a really good point there, Ella. You know, some of those terrible weeds that we have so much of, things like Tradescantia and you know, all sorts of nasty weeds that have really bad root development. If they're allowed to actually occupy those areas, then yeah, you're right, Ella, the banks just get sort of smashed by flood. So, you know, weed control is another issue, isn't it?
Hopefully we have answered most of your questions. I'm just aware that it's nearly 7:30. I'm just putting in a link to that climate action webinar next Tuesday evening if you'd like to attend, and also to the Eco Fest West page. I would just like to acknowledge Matt and Ella for both giving up their time and for all the amazing work that they do. And it's such a privilege, you know, to share this work with you guys, and also to everyone at home who Limon came out and sat in front of a computer, even though I hope it was worthwhile. I know that it's frustrating having so much Zoom time. So I'm really grateful for you to come along, and we're going to wrap it up there. We're just going to end with a karakia as we closed with a karakia. So I will just quickly put it onto that. If you do want any more information about any of this stuff, you can contact Sophie at communitywaitakere.org.nz, or you can find Community Waitākere on our Facebook page. So I'll just close with this karakia, and the translation is on the right. Kua mutu a mātou mahi mo tēnei wā, Manaaki te mai mai katoa, o mātou hoa, o mātou whānau, ai o ki te aorangi. Thank you all for coming. Yes, the recording will be available to participants. I will email it all out to you and also put it on our Facebook. And I hope you have a lovely, slightly rainy, snuggly evening.
Kia ora,
Thanks so
Sophie.
much,
Thank you.
guys. No worries. Pō mari, everyone. Have a good night.
Ka kite.
Bye.